Alright, so we're going to look at right triangle trigonometry. Now, this is a skill that you've seen before. We're going to take it a little bit more in detail, but we're going to just go over the basics real quick with trigonometry. Trigonometry brings in our sine, cosine, tangent, cotangent, cosecant, secant functions. And what we're looking at is that two triangles are similar if the angles of one are congruent to the angles of the other. That's basically how we know two triangles are similar. Well, when we look at right triangles, we only need to know that an acute angle of one is equal to an acute angle of the other for the triangles to be similar, which then gives us a way to determine the six distinct ratios of the side lengths of the triangle. In order for us to look at the right triangle, we can bring into play the coordinate system. And with the coordinate system, we know this is x and this is y. Well, with the coordinate system, we start here and we have this angle here. Now, before when we did line of travel, we went clockwise. But when we start talking about our angles and our polar coordinates and we start getting into our more trig problems, we do counterclockwise. So, in order for us to bring in triangles and convey this with the coordinate system, we're going to look at this particular angle here, and we call this angle theta. We call that angle theta. When I'm going to trace this so that you can see. When we start at the x-axis and move counterclockwise in this particular direction, we say that this is standard position. And basically all it says is that one ray, and that's a ray because that's an angle, one ray is along the positive x-axis. And that's how you know you're in standard position. And then the other ray extends into any of the quadrants. That's just being in standard position. Okay? But then when we look at an acute angle in standard position, for an acute angle in standard position, same thing applies. One ray is along the positive x-axis, but the other ray is extending only in the first quadrant. And that's because of the word acute. Remember, our acute angles are between 0 and 90. So that means theta has to be greater than or equal to 0, but less than what? 90 degrees. So it cannot be 90, but it can be 89.9 degrees, and therefore that is an acute angle. Okay? So now that we have established what standard position and we've established what an acute angle, we can look at the trig functions. And I'm going to cut trigonometry short and just put trig functions. And you'll hear me say trig a lot instead of trigonometry. We're going to define the trig functions for a right triangle. Okay. So we're going to let theta be an acute angle. In our right triangle, ABC. Okay. When this happens, we have our 6 trig functions. And I'm going to draw it so that you can actually see. No matter which way you draw, you'll be able to tell what's going on. So here's my right triangle. It doesn't really matter which way you label this. I'm going to do A, B, C. And I'm going to let theta be up here. So that's my theta. I'm going to change my mind. I'm going to change my mind here. Because most often you would see C as your right angle. So I'm going to change that to A, B, C. Because most often you will see C being the right angle. Okay? So now that we have this, we can talk about the angle theta. And theta here, if we look at this right angle here, we're talking about this angle right here, which is theta, which is also angle A. This is going to be our opposite side because it is opposite this angle. This is going to be our adjacent side because it's adjacent that angle. And of course, we know this is our hypotenuse. Okay. Okay, so from that, we end up with our different trig functions. Sine theta, which is short for sin, and then we're going to put theta. Please do not say sin. It is not sin. It is sine theta. Okay, we just abbreviate it with sin, but it is sine theta. I will take points off of you if you say sin. Okay, so sine theta is going to be opposite over hypotenuse. And y'all remember this. I know y'all did SOHCAHTOA, but I'm just going to continue to go over this. Then you have cosine theta, which is going to be cosine theta. And please do not say cos, because it's not cos, it's cosine. Okay? And cosine theta is adjacent over hypotenuse. And then you have tangent. And tangent theta. Now this is the only one that you can say tan theta. So when you see this, you can actually say tan theta. So tan theta is going to be equal to opposite over adjacent. Okay. The other three basically goes in coincides with sine and cosine and cotangent. So then we have cotangent theta, and you don't say cot, you say cotangent. Cotangent theta, it means exactly what it says, the co of tangent. So basically it's adjacent over opposite. You just flip your tangent. Then you have cosecant theta, which is cosecant. And this is going to be the reverse of our sine. So cosecant theta is the hypotenuse over the opposite. Or you could say 1 over sine theta. Okay. I'm running out of room, so I'm going to go right over here to the side. We have our secant theta, and it's secant theta, and it's going to be the reciprocal of our cosine. So secant theta is going to be the hypotenuse over the adjacent, or you could say 1 over cosine theta. Okay. So let's look at an example that we can look at with these particular triangles that we have, and it's just a right triangle. We're not saying that the triangle is going to be 45 45 90 or 30 30, 30 60 90 degree triangle just yet. That's a whole nother issue. Right now we're just going to look at a triangle and be able to tell what the ratios of the 6 trigonometric functions are going to be. So your example that I'm going to use is a triangle that looks like this. This is 5, this is theta, this is 4, and this is 3. Here's my right triangle. Okay, and we're always going to right now do it with respect to our angle theta, unless it otherwise tells you to look at another angle. Okay, so sine theta, cosine theta, tan theta, cosecant theta, secant theta, and cotangent theta is what we're looking for. Okay. Now, if you go back and look at your notes, you recall that sine theta is going to be equal to the opposite over the hypotenuse. So we look at our theta. Here's our theta right here. Now, which side is opposite of this? And it would be the 4. So it's 4 over, and of course this is going to be our hypotenuse, and so therefore this is going to be 5. So what I like to do is put opposite, hypotenuse, and then this is adjacent. That way we already have it labeled. So then cosine theta is going to be adjacent over hypotenuse, which is 3 over 5. And tangent theta is opposite over adjacent. So opposite over adjacent is going to be 4 over 3. Alright, so then we look at cosecant. And remember, if you looked at cosecant, remember it was going to be the hypotenuse over the opposite. Or we can simply say it is 1 over sine theta. 1 over sine theta. So basically all we have to do is flip our what? Sine. So this is 5 over 4. Secant now is going to be 5 over 3. And our cotangent is going to be 3 over 4. Pretty simple enough. Example 2. That doesn't really look like a right triangle, does it? Let me try that over again. A little better. And I'm going to label this A, ABC. And this time, I did not label the actual angle that I'm looking for, but this is what I'm going to ask you now. Oh, I guess I got to put the numbers here, don't I? Let's go with the square root of 113. Let's go with 8. And let's go with 7. Okay. So now I'm asking you, what is sine of A? So now we look at angle A. And because we're looking at angle A, I want to do the opposite over the hypotenuse. Opposite over the hypotenuse. So here's my angle A. The side opposite of that is 7. So this is my opposite. And of course, this is my what? Hypotenuse. So sine A becomes 7 over the square root of 113. Now, we don't leave the square root in the denominator, so we go ahead and rationalize it. So we're going to multiply by the square root of 113 to rationalize that. So it's 7 square root 113 divided by 113. And we can leave it like that. Okay. So what if I want to know what is cosine of B? Okay. So now I'm looking for cosine B. So here's my angle B right here. So cosine is adjacent over hypotenuse. So if I look at B, this is my what? Adjacent side. And this is my hypotenuse still. So this is going to be 7 over square root 113, which gives us the same answer as above. The reason why we get these two the same answer is because I'm talking about two different angles. I'm talking about angle B for cosine and angle A for sine. And you can do that. It just depends on which angle you are talking about. But you don't ever talk about the 90-degree triangle or the angle. We always look at our acute angles for our angles that we want to find the 6 ratios for. And the trigonometric ratios hold only for right triangles. You only can use this for a right triangle. Okay? So for tonight's homework, I'm going to go ahead and give you, I was going to upload it, but I'm going to go ahead and write them down so that you can have them and you can find what you need to find. Okay? So the direction says, given a right triangle, find each trig ratio. Leave your answer as a fraction. Sine A, cosine A, and tangent A. And then I want you to find sine B, cosine B, and tangent B. Okay? And that is it. Have a good evening.